Good morning, good afternoon, everyone. My name is Pankaj Miglani, and I'm a security specialist partner solution architect here at AWS. And I'm here to talk about identity best practices that can help you elevate your AWS security posture. And I'd like to thank you for your time today. And with that, I guess I will stop my webcam to avoid any jitters causing any bandwidth issues that may hinder my voice. All right. So the talk that I'm doing today, this is inspired and modeled from our CISO Stephen Smith's security leadership session. He covered a broader base than me and discussed the top 10 places where you should focus from security perspective and not just identity. But the presentation I'm doing is more focused around identity best practices. And I would encourage you to look at this presentation from Stephen. I've included the link over here, which is more around how to make sure that your application is well architected from a security perspective. So when we say identity, what is identity actually? So for me, identity is the system you use to authenticate your users and authorize them to have access to all the right information that they need to do their job. And the foundational service for identity in AWS is IAM, Identity and Access Management. So if you are using AWS, I promise you are using IAM. All our services use IAM for decision making around how to grant access to different resources. So with IAM, you can create users and groups and associate permissions to these users and groups to allow or deny access to various resources. In the field, I'm often asked for prescriptive guidance on IAM, and today I'll be providing you those top 10 identity best practices that I straight away recommend in the initial discussions itself, which can help you build and assess your AWS environment and ensure that it matches our experience of what best practices look like. So let's get going. So the number one. So I basically what I've done is I've created three different categories of these 10 best practices. So the first category is set of three controls, which is three best practices highlighted in amber over here. This is mainly around the concept of having multiple accounts and organizations. This helps you scale and manage the complexity when you have maybe more than one application, more than one workloads, or a number of users in your environment accessing different resources. The second category, which is the purple one over here, is purely around users. So like how you authenticate the users and how do you ensure that you have the right users connecting in the right fashion. And the third category is around permissions. So basically, how do you continuously review your policies for permissions? How do you audit IAM for any unused principles or monitor your resource access? So this is to make sure that you are providing access based on the minimum information that your users need, which is effectively the principle of least privileges that is being taken care of or not. So let's start at the top and look at number one. So the number one is multiple accounts. When you first sign up for an AWS account, you'll be signing up with an email address and probably you'll put in your credit card to pay for it. So as you turn on additional AWS services and add more and more users to your account, you will start to use AWS extensive security controls to manage your permissions to make sure people only have minimum access. So there are some limitations to that approach, and soon you will start using the most powerful security boundary, which is the account boundary, and you should be using multiple AWS accounts. This gives you more power in terms of managing production versus test versus development accounts, or be aligned with your organizational security policies wherein you need to manage separate environments into different accounts. And it also helps you with cost accounting. so you know where your dollar numbers are coming from at the end of the month. And as your account count increases, you will quickly discover the account management service called AWS organizations. So AWS organizations lets you create groups of accounts called organizational units. So you can apply policies either at the account level or to your whole organization or in between on the OUs. So you can essentially manage policies across multiple accounts without requiring custom scripts and manual processes uh, to manage those permissions. Please do note that an AWS account can be a member of only one organization at a time. And when you enable AWS organizations, you want to turn on the all features mode, which is kind of gives you access to advanced features and gives the management account of the organization full control over what the member accounts do, including ensuring that the member accounts don't leave the organization. And it enables consolidated billing for you as well. So as I mentioned, AWS organizations lets you have multiple accounts under it, and it also lets you create organizational units and structure your accounts. And that's my second best practice for you today, which is creating intentional organizational unit structures. So make sure that you are using an intentional organizational unit structure. By intentional, I mean understand your business and your information security requirements, your workload requirements, your data sovereignty requirements, and then take a look at creating that criteria of what your organizational environment should look like. It's a very powerful tool, powerful service, as you can use it to make sure that your organization reflects your environments and maybe even reflect your business culture or your operational culture. So there are two solutions that AWS provides to help you set up your multiple account infrastructure for you. And those solutions are AWS Control Tower and AWS Landing Zone. So both of these are powered by AWS organizations. But they automatically, and they also automatically implement the organizational structure that I've shown over here on the screen. And once you implement that, you can go ahead and create further organizational units based on your requirements. For example, you may have a dedicated sandbox account, or you may have a dedicated staging area. So depends on what your requirements are. You can segregate these accounts into different organizational and under different organizational units as required. So once you have your organizations with your multiple accounts and your thoughtful OU structure, I recommend that you use immutable security controls that you can enforce at a wider level. These immutable security controls are nothing but the security control policies, or the SCPs, which you can enforce at an account level or the organization level or the OU level. So with an SCP, you can define the set of rules about what is allowed in the account, like what you can define a list of APIs that are allowed, or a list of APIs that ought to be blocked and can't be overwritten by a local administrator. The key point to note is that SCPs are only guardrails and they don't grant permissions. They are necessary but not sufficient for any user to have access. I put some example SCPs that I thought you might be interested in over here, like a restrict region SCP would allow you to restrict access to the regions you want to. It is quite common in the Asia Pacific and ANZ that organizations would restrict the regions to AP Southeast 1 or AP Southeast 2, which is like Sydney and Singapore, due to operational reasons or data sovereignty reasons. Similarly, you can deny access to any AWS service that you didn't intend to use, thus reducing your overall threat landscape and blast radius. Now, we transition into the second category, which is more around the users, right? And the first foremost best practice is to secure the root itself. So the root account is held by the email address that you used while signing up for the account. So should you use the root for day-to-day operations? That's a strict no-no. There is a set of admin capabilities like changing your support structures for which root is required, but other than those exceptions, root should never be used. Think of it as an account to be used for emergency fixes, maybe for break glass capability, or setting up your billing for specific reasons at the root level itself. Yeah, so delete your root access keys and use SCPs to make sure that you can't do everyday operational activities with root. Uh, it's recommended to set up the notifications for any time anyone logs into the root account, and there is a well-polished blog around setting up notifications for whenever root is used, which you can look up at the AWS security documentation. In terms of additional techniques to secure the root, we recommend to enable MFA. With MFA at AWS, you can have a hardware token or a digital token. And with the hardware token, you should ensure that you connect every 3 to 6 months so that there is no time drift. Use strong random passwords. AWS allows you to use like 128 characters, and I would recommend to use more of that space rather than less. And if possible, split controls. Have systems where you have two pairs of hands on the keyboard. Like the person who knows the password should not have access to the MFA token and vice versa. And finally, take steps to protect the root account recovery process as well. So the email address used to sign up should not be of an individual who, for unknown reasons, moves out or is not reachable. So prefer having the address of a distribution list so that there is a service team responsible for recovery. Similarly, for the permanent telephone numbers on the account, have strict controls over who has access, who can have access to that phone and can answer those calls. So we know that we are not using root to log in. Then what identity should we be using? The answer is the best practice, which is like Federate identity for human access. So unless you are born in cloud, you would have some form of corporate user directory, like Active Directory or LDAP, and that corporate directory is the source of truth for who works at your organization. And you should not be spending effort in maintaining two copies of that, and effectively have an extra set of identities configured in AWS IAM. So effectively, when you federate, rather than making a second copy, you configure AWS to query your company's existing corporate user directory for validating the users. And when we avoid creating users in IAM, we move away from those long-lived credentials, and federation thus allows the reuse of identity. So you can easily set up federation using AWS single sign-on, which allows you to manage user authentication to all your AWS accounts in an organization. And there are a lot of partner tools available, like as visible on the screen, like Azure, Okta, OneLogin, which can act as identity provider and allow you to manage your trust relationship between your corporate user directory and AWS accounts. All right. So once you've federated, what is the best way to assign permissions to the federated users? That is our number 6 best practices. Best practice: use roles. You absolutely need roles for federated users, but even if you have standard IAM users, you should still be using roles. You can define role-based access control based on the job function, aligned to the principle of least privileges, and then basically ensure that the roles that you have defined are simple enough. Limit roles to one level of role assumption, right? So I guess, yeah. So limit role assumption. So it shouldn't be like, if you end up using role chaining, like you have set up role A, which can assume role B. There's nothing wrong with that from a theoretical perspective, and it should work fine. But my experience is that it makes it harder to understand who did what and respond to incidents. So these role hierarchies just complicate the attribution. So whenever possible, just have one level of role assuming a role in terms of attribution. And third, segregate the different purposes of role. You should have different rules for human and machine access, and you should not let multiple applications use the same role. Okay. Now, so till now we have covered how to set up the account structure and how to authorize the users. For the rest of this session, let's talk permissions, right? So the principle of least privilege is a foundational security principle which says you should have the minimum access necessary to do your job. So we know we are trying to avoid broad access to our data. How do we do that in AWS? So that is what is our next best practice, which is continuously reviewing your policies. To start with, there is one really useful tool, which is IAM Policy Simulator. It's kind of a sandbox which takes a question and command, and then it gives you an output in terms of whether a policy is feasible or not. For example, would user X be able to delete the database? You could simulate the policy without risking the database solution in your database in your account. Just try the simulator, and you should be able to figure out what the output would be. And also have a look at the Access Advisor, which gives you a report that has a list of services and timestamps for when they were last used. So the service last access data is available for your accounts, OUs, and your organizations. And you can use this to find any services that are being used by IAM users and roles. So one example of how you could use this is you could identify services that aren't being accessed, and let's say in one given OU in the last 90 days, then you can implement a control like what we talked about earlier, SCPs. So you can create an SCP that denies access to those services and attach the SCP to the OU so that you restrict access to all IAM users and roles across the accounts in that OU, reducing your overall risk exposure. All right, so next one is you should always be auditing IAM for unused principles and deleting any unused principles that aren't being used in your account. And the tool to help you to do that is IAM Credential Report. So this tool will help you delete stale or unused account keys or IAM users or roles. So it generates a CSV file so you can do it either via the console or via the CLI. So you get information like is the password enabled? For example, here in the picture, there is no password enabled for root, so they are good. And when was the password last used? And here it looks like Bob never logged in, which means that the account may not have been needed at the first place. It also gives you information about when it was last rotated. So this would be the place to check if your information security policies like password rotation are implemented or not. In addition to user accounts and passwords, it also gives you information about the access keys. So whether the access keys are enabled, if they have been rotated, if they have been used, and based on that information, you can do your decision making in terms of what are the principles you need to stick to, what are the services you need to stick to, and what needs to be disabled in your environment. In the end, I would so you should also monitor your resource access. It's still about permissions, right? But from the perspective of resources, and the goal is to be persistent as before. Aim for the least privilege in your for your resources and to users. So one powerful S3 feature that everyone should be using is block S3 public access. So this feature of S3 overrides all other S3 permissions. It's designed as an easy centralized control that you can just turn on to block all public access. It applies account-wide for all current and future buckets. And another tool, and obviously there are exceptions wherein, for example, you are doing some static content hosting from your S3 bucket. You need to ensure that there are exceptions in place for that for that S3 bucket. Otherwise, enabling this feature would automatically prohibit people from accessing that bucket from the public port. So another tool I would like to touch over here is the IAM Access Analyzer. Use IAM Access Analyzer to figure out answers for questions like what is shared outside my account and what is shared outside my organization. And you can build detectors to answer those questions in whatever regions you are using. So the type of resources it monitor is like S3 buckets, IAM trust policies, KMS keys, Lambda functions, and SKS queues. So basically, the resource types that support a resource policy are the ones that you can monitor via this specific tool. So we've covered a lot of best practices over here, but are we done? Well, no, there is always more in the security world. So based on the level of granularity and insights you need and the environment maturity, you can keep on increasing the security posture. You should start using the permission boundaries to increase the level of control on the permissions that specific users and roles can inherit from creating roles or users. Uh, Start using IMDS V2, Instance Metadata Service V2, which gives you an extra layer of protection against misconfigured firewalls gaining access to EC2 credentials. And certainly, automation should have a huge focus when you look at increasing your security posture. So if you build your CloudFormation templates with well-secured blueprints or vending well-formed accounts through Service Catalog, those are some extremely powerful tools to help with automation. The list over here is just in terms of what you can do, but there is no end to it. As your security posture increases, you can go on refining your security controls and in terms of safeguarding your resources and ensuring that the risk exposure is limited. So the key takeaways I would say is use the isolation power of AWS organizations and accounts, federate identity into highly granular roles with limited trust policies, use IAM tools like Credential Report, IAM Access Advisor, and you can get highly granular roles and be strict in your trust policies. And finally, use these tools that I mentioned and watch out for the new identity-based features later in the month during the event 2021. With that, I'll thank you for your time today, and I'll pass on to Ron or Brad.